right, we are going to get out of the shadow there a little bit, or out of the sun into the shadows here a little bit. All right, so we're going to chapter 2, starting chapter 2 already. Kind of cruising right along here. So chapter 2 is what we're going to concentrate on about the next week and a half. Chapter 2 is going to deal a lot with equations and functions and all of those different types of things within this, within this unit. It's about a 6-section unit, so we'll cover it in about 7 days-ish, somewhere right in there. So about a week, a little over a week, week and a half. We'll try to get things done. Today, what we're going to do, we're going to talk about section 1. So we've got 2.1 today, which is linear equations. So we've got linear equations that we're going to work on today. Really linear equations with one variable, so x's. So we're going to look at solving linear equations. What makes a linear equation? How do we know if an equation is linear or not? How to solve linear equations using different properties, the distributive property, how to solve some linear equations that have fractions involved in them, and so on and so forth when we're dealing with linear equations. So first, how do we know, one, that something is an equation or an expression? How do we know that something's linear or something is really not linear? So first of all, let's talk about what makes an expression and what makes an equation. So an equation has an equal sign. That's a nice N, by the way. So you're going to have an equal sign when you are dealing with an equation. So something like 3x minus 7 equals 2. That's an equation. We can take this equation and we could solve this equation. Okay? If you were asked to solve this, you could, because it's got that equal sign. So that's considered to be an equation. An expression doesn't have an equal sign. So no equal sign in an expression. So really that first part, like 3x minus 7, there's no equal sign in there. So we call that an expression. There's no equal sign. So again, we call that that expression. So if we want to be able to tell the difference between an expression and an equation has an equal sign, an expression doesn't. Okay, so then how do we know if an expression then is linear or not? Well, linear means line. So an equation in one variable, so a linear equation in one variable can be written ax plus by equals c. Now, keep in fact that a, b, and c are real numbers. Okay, so a, b, and c are real numbers, and a can't equal 0. Okay. That's what really a linear equation is. It's anything that really can be written in that form. A linear equation is a first-degree equation, and the greatest power it can be is 1. So when you're looking at these, it can't have a power really that's greater than 1. So you're not going to have any powers here. You're not going to have x to the second. You're not going to have any exponent, so to say, when something is linear. It's just going to be something that's really written in that form. So the first thing then that we want to be able to do is we want to say, okay, well, if we have something like 9x equals 10, first thing we want to decide if it's an equation or not. Is it an equation? It's got an equal sign, so it's an equation. Is it linear? Can it be written where we've got like x equals something? Yes, so then this is linear as well. There's an E in there. Okay, so that's linear as well. Well, what if we have 9x plus 10? There's no equal sign. So this is an expression. If it's an expression, it's not linear. Okay? In order to be linear, it has to be an equation. That's an expression. If we have something like 3x plus 5 plus 4x minus 8, if we look at this, there's no equal sign. So again, this is going to be an expression. If we take that same thing and say 3x plus 5 plus 4x minus 8 equals 10, now it's an equation. Okay. Is it linear? Sure. You could simplify it to 7x minus 3 equals 10. 7x equals 13. And so then it's going to be linear then as well. Okay. So we got to be able to tell the difference between if they are linear or not, if they're equations or not, and also if they're linear or not. So let's look at a couple more where we want to determine if they are going to be linear. Okay. So a couple other tips really to decide if something can be linear or not. If a variable in an equation can be replaced with a real number that makes the statement true and that has in the solution, it's an equation. An equation can be solved by finding a solution set. Equations essentially can be solved. Okay? If it's linear, we're going to solve it for an x, or we're going to solve it for a y. That type of thing where it's kind of this singleton thing. So something like 3x plus 4y equals 8. This is a linear equation. Our x values aren't taken to any powers. Our y values aren't taken to any powers. We've got no square roots. We've got nothing really like that. So this is considered to be a linear equation. If we have something like 3x squared plus 2y equals 8, you notice that we've got an x squared there. Since we have an x squared right there, that automatically makes it nonlinear. It's not going to be a line. Linear is line. It's not going to be a line. They only can be essentially written in this form, or you could have, 3x equals 10 or something like that. That's going to kind of form really that line, y equals 8, whatever. That's what we're going to have when we have something that's a linear equation. Okay? So the next thing we want to be able to do then is we want to be able to solve equations. And solving equations is something you've been doing really for quite some time. Solving equations really isn't going to be anything that's new to you. So for example, let's say that we want to solve the equation 4x plus 8x is equal to negative 9 plus 17x minus 1. And we want to take this equation and we want to solve this equation for x. So what does x equal? Well, again, kind of trains of thoughts with this. There's several different ways to do it. Sometimes you'll see the lines. You guys shouldn't need the lines at this time. You've gone through Algebra 1 and Algebra 2. So combine like terms, 12x, and then you get 17x minus 10 on this side. The whole thing about this now is isolating. So I'm going to subtract 17x from both sides. So you get negative 5x on the left-hand side and negative 10. I got a step ahead there. Negative 10 on the right-hand side. get rid of multiplication by dividing, so you get your x value is 2. And that's your solution. Now you can either write that in one of two ways. If it's just asking you for a solution, that's your solution. You could also write this as a solution set. The solution set could be written something like, you've got our brackets and you've got a 2. That's your solution set, okay, when you're dealing with these different types of problems. Okay, let's look at another one. So let's say we have 3x plus 8 equals 3x minus 10. Well, we've kind of got a couple different things going on. Right, again, get things on one side. So I'm going to subtract 3x, and again, you should be able to do multiple steps at this point. Subtract 3x from both sides, and I'm going to subtract 8 from both sides. So in this case, everything over here cancels. We get 0 equals negative 18, which is a false conclusion. 0 doesn't equal negative 18. Since this is a false solution, our answer is the empty sets. There are no solutions to this. Okay, so that's the empty set. That means there's no solutions. If you get something like 7 equals 7, that's true. If you get that true statement, then it's all real numbers. Is your kind of your solution set for that. Anything you put in there for the x value is going to work when you do these. Right? So that's solving equations. And again, this is something you've done before. Let's just look at a couple more examples of things that maybe are just a little bit more complex as far as solving things go, using a couple different properties. Let's go with 6 minus, and then a parentheses, 4 plus m equals 8m minus 2 times 3m plus 5. Okay, I'm going to put a little filler in here right now, not in the video. Go ahead and do this problem on your own, and then the answer will kind of be on the other side. Okay, so you can kind of see what I've done now. I didn't really walk through it too much. You can kind of see the value of m that you should have got down there is m is equal to 4. And the kind of the nice thing about solving equations is really you always can check your answers to see if it worked. Plug 4 back in there and see if you get something equals something. In this case, I think you'd get -2 equals -2. But you can always check kind of your solutions to make sure you've done really what needs to be done. And the last type of question that I really kind of want to look at is I want to look at kind of fractions, because those tend to give us a little bit of issues. So let's go 2/3 r equals -6 or something like that. Okay. Anytime you're dealing with fractions, the first thing I would do is kind of isolate a fraction if you can. If it's with a variable, kind of get that on one side and everything else on the other. Now you're going to take a peek at the denominator. And that denominator is going to be kind of your key. Because what you're going to do now is you are going to take and multiply both sides by whatever that denominator is. Because then what happens with that denominator is that denominator crosses out on, in this case, the left-hand side, and you're left with 2r equals, in this case, -18. And now you've got rid of those dang nasty fractions, and you can divide by -2 and get r is equal to 9. And there's your solution for this. And again, you could correct this and check this really if you wanted to. Well, what happens if you've got like multiple fractions going on? Let's say we have 3/2 r, nice r, plus 1/4 r equals 8. And fractions are a whole lot of fun, so we really don't want to deal with them. We could combine these, but why combine them? We've got the r's on one side, we've got everything on the other. I'm going to multiply all of these by something. And the something I'm going to multiply these by is, in this case, I'm going to multiply by 4, which is really a common denominator for 2 and 4. When I do that, I'm taking 4 times 3. So 4 times 3 is 12. So that gives me 12r over 2. Plus, I also have to take this. So this gives me 4r. Yeah, 4r over 4 is equal to 4 times 8, which is 32. Well, 12r over 2, 12 divided by 2, so that's just 6r. So 6r plus 4r over 4 is just 4 equals 32. So 7r equals 32. So r equals 32/7, and that's how we would just leave this one as a fraction. But we can get rid of those fractions by multiplying by kind of the least common denominator, and then it kind of eliminates those different things. Remember, when you take fractions, it's top times top, bottom times bottom. So that's why it's 4 times 3 and 4 times 2 in those different types of situations. So that's kind of solving with fractions. You're going to have a few of those in there today as well. But really, that's really kind of it for today. Everything is solving equations, being able to tell if something is linear or not, and being able to tell if something is an expression or if it is an equation. Remember, it's an expression, no equal sign. It has an equal sign, then it is a equation. Okay, have a great day, everybody. The assignment, if you notice, I did put the paper assignments in there. I would prefer that you do them in Pearson. That's how I want you to do them. I'm just going to put them on here in case for some people just like to see them on paper copies, and that's fine. You can do it on the paper, but please transfer it over to the Pearson online and do it in there. Don't turn in the paper copy. Don't submit the paper copy. But you can do it on here and then just kind of transfer it over. And yes, I know the answers are on here. Yes, on the paper copy, the answers are right on there, but just make sure that you know how to do it and what's going on. So that does it for today. Get yourself to work. We will talk to you probably like right now because you're right in front of me, or you're sitting at home watching the video and you're good to go. Take care, everybody.